Hey everyone, welcome back to Devs in the Sheds. Hey there, Paul. Hey Andrew, I'll introduce you in a second. This week on Devs in the Shed, we actually have Aaron away. He's over in the US this week, so apologies, Aaron couldn't make it, but he'll be back next week for Devs in the Shed. For everyone that's new to Devs in the Shed, well, as you can see by Paul and myself, we basically hang out. We do work on our laptops within our sheds that we've got in our backyards. We have a bunch of IoT devices and lots of different like DIY types of tools for different projects in the background as well. So when we're not coding and we're not working on our laptops, we're probably playing with something in the background. So Devs in the Shed is really a show where we get hands-on with the AWS tools, but we also show off a whole variety of things. And I think this week's going to be a really fun one. So I guess Andrew is here as a special guest to cover event-driven architecture. He's going to go through a bunch of different patterns with everyone. Feel free to ask questions in the audience as we go through this. He's going to be a wealth of knowledge. We'll get started with him in a second. The first thing I did want to do is hand back to Paul very quickly. I think you had something that was a new release in AWS land that you found quite interesting today.
Yeah, so before we go and we do, Andrew does the introduction about his role and what he's been doing with event-driven architecture. A lot of this, some of this spun out of some work that we were doing around our customers talking to us about like integration platforms, certain integration platforms, taking data from one platform and inserting it to another, and how you can go ahead and leverage that. There are specific technical patterns and implementations around that, which is what today's session is about. But it was also a really good caveat when Andrew and I were talking about like what the show should go through to and what we should talk about. I also wanted to mention and talk about like our product, our AppFlow product. And AppFlow is effectively what I would say like our AWS's cloud native connector, and that helps to integrate specific third-party data sources. So, for example, you can like connect directly to Salesforce and take data from that and push it into other sources within your environment, your platform as well. So there was an announcement this week that I thought was worth mentioning. And this, I think this is like reasonably common. So I'm going to paste it in there so the audience can have a look at that. But Amazon AppFlow now supports Facebook ads, Google ads, and Mixpanel as data sources. So you can pull information from those places. Now, thanks for showing that up, Matt. So I've worked in a number of different organizations where, understanding what your customers are, doing and becoming involved with your application, it's really, really important. And the same goes to like how all of these pieces of data are split up. So understanding that you're, publishing and building like events and ads to like multiple different platforms there. That can be tedious and difficult. Trying to bring all that data together, doing manual exports from each one, or having reports in each different advertising provider is really difficult. So I know that I've used Mixpanel in previous roles. Mixpanel is again a further set of aggregators to be able to like suck data in from other providers. And now AppFlow has built-in support to be able to connect to those all of those three at once. So this is like a good mechanism for accelerating the centralization of some of that data when you're trying to pull it together and really dive into insights across those different advertising brands. So I thought that was worth mentioning today. So yeah, that's where it is. But as Matt said, like how is everybody today? So I know that Aaron is in Boston. I'm in Victoria. So is Andrew. So is Matt. It's been pretty cold. Matt and I, today we're not in our sheds. We are both in our cabins. I think cabin and shed is close enough. Matt's is much more, how do we say, like polished. Mine's much more rough. So it's been like weeks or maybe months since I've like done it outside in my actual cabin. But I'm out here back again now. I've got like my whole electronic setup out here in the background. I've brought some of my like little devices, but some of my Raspberry Pis I've brought back inside. But one of the things we're talking about was in some point in the future, we'll talk about the M5 stack and we'll work with that like little IoT device. It'd be interesting if anybody in the audience has ever used M5 stack, and if you think that would be something interesting to show. I think it's really cool. My son likes to look at it too because you can make it vibrate and show things on the screen and stuff. So pretty cool.
Yeah,
But
and you're very brave, Paul, because it is 9 degrees Celsius. So I don't know if you can do the maths from your time in America, but what is that in Fahrenheit? Is that like 30 or
I don't
40
know.
Fahrenheit?
It's yeah, it's cold. I think actually right now it says it's 10 degrees where I am. I just
Yep.
quickly checked, but it feels much colder, and probably as you can see, like over there, like my cabin needs some work. That is gaps to the outside, so it is cold.
Yep. You need some insulation.
Yeah.
Excellent.
So
So
let's introduce Andrew.
yeah,
Andrew,
I was going to say, Andrew, can you tell us a little bit about yourself? Tell us what you do at AWS, what your background is. Just give us a little bit of a flavor first up before we kind of kick into the architectural side.
Yeah, sure. Thanks, Paul, Matt. Thanks for having me on Devs in the Shed. Great to be here. I'm wearing a t-shirt today, by the way, but I'm actually in my office inside, so I'm not as brave as you both. By way of introduction, so I work at AWS. Been here for around 2 years. I work predominantly with our energy customers, and my background has been as a software developer and also working across the energy sector here in Australia. Yeah, be good to chat with you guys today.
Nice software development. What languages have you used? I'm sure people in the chat would be interested in.
Yeah, okay. So I pretty much learnt in Java back in the day, and then done quite a few, but I think mainly the one that we sort of work with at the time was C Sharp,
Yep.
predominantly. So that was probably my favorite flavor for quite a few years, but I'm trying to branch out and do a few other things. So I typically write a lot of stuff in TypeScript or JavaScript these days.
Nice. I think most of the audience are TypeScript and Python, but we've got a few people throughout the weeks that have done a bit of Java and C Sharp. I know that Aaron he loves developing in C Sharp. Nearly everything that he does is either TypeScript or C Sharp.
I think
But
that's a pretty common developer.
Yeah, it is. It
Go
is.
to C Sharp and to TypeScript it's a natural progression. It feels very similar. I mean, TypeScript comes from Microsoft. C Sharp from Microsoft. So yeah, I've seen a lot of people move across to that.
Yeah,
Yeah.
in Java and C Sharp, both the enterprise level, development languages of choice, I guess.
Yeah.
Yeah.
Now, before you go in and start showing us some interesting stuff, Andrew, there is something very, very interesting in the background at your house. Now, I spotted it, and so did Matt. We asked about what it was. But the
The
audience
snow
needs to know
cone.
what that is. There's a device
Ah,
to your left.
I was
Hang on.
thinking of the poster with that band that I used to listen to a lot when I was younger.
I mean,
I have
that
plenty of
will be
those as
interesting
well.
for people that know
Yeah.
music. I mean,
So
when,
what
Here is
is?
here is an AWS snow cone. So this is an edge device that you
Hmm.
can get, which is basically you can go into the console and select one to actually be delivered. So I'm doing some demo work and preparing some content for that for some of my customers. But basically, you can run EC2 on it, EBS, those types of things, and get those volumes on here and connect it to the cloud really simply. So I'm actually running ECS anywhere on it. So I've got some containers running on it, and going to do some work with some satellite projects.
Nice. And just for people that don't know snow cone, let me just share my screen for 2 seconds. We always get asked this, so I'm gonna jump ahead of the audience, right? So let me get my screen up. So snow cones, if you want to order one for yourself, they're $60. You pay per day, so the first 5 days are free, and then you pay $6 each additional day that you need a snow cone. If you go for an SSD snow cone, so top of the line snow cone, it's about $150, and then $15 per day. And then data transfer out is there's a cost associated with that. But if you're transferring data that go into AWS, it's going to be free. So I guess
Yeah.
do you want to kind of explain a little bit of how snow cone works? Like you've got it in your house, but what could you potentially do with AWS with it?
I actually only got it yesterday, but have been playing around with it. But there's a couple of different options you can use with it. So you can either use the snow cone or the snowball device, in this case, to ship large volumes of data. So you can actually have your I guess, S3 location on that particular machine, and then ship all your data onto it, and then send it back to AWS. Therefore, you can actually get the data loaded in there in a safe and secure manner if you don't have that particular connection available. Or you can actually have a snow cone available as edge compute. So you can actually have a single which will run and, say, collect analytical data from, say, devices. And I know you guys have done a lot of work with, say, Monotron and so forth. And you can run, say, IoT Greengrass at the edge, and you can do some analytics there with it. You can also cluster them too. So you can buy multiple of those particular machines and get them clustered. But I've just got the one here at the moment and just, playing around with that.
So Andrew, when you have the snow cone at home, do you use the AWS control panel and control plane to be able to access the device and create virtual machines? Like, how do you do that? Do you have a separate interface to do that?
Yeah, so there's a separate Fit client application that you can download called OpsWorks with it, and that gives you the ability to unlock the device and pretty much interact with the device, either be it locally or either be it remotely. So that way you can then check all your EC2 instances that are on it, the volumes that are on it, those types of things, and the networks that are available.
Cool. So yeah, I guess it's like having a mini version of AWS Outpost with less features, of course, but you can effectively run your own AWS cloud at home. But with the EC2 and Greengrass and some EBS block volume stores and S3 and so forth locally.
Yep.
A bit of a rewind though. Like what is Outpost? I mean, both Paul and myself have tried to get our managers to let us order them to our house, but how would you describe Outpost to people that haven't seen that as well? Because a lot of the stuff that, like, hardware-wise, people just don't see when they use AWS, right? Has anyone in the chat ever had a snow cone delivered to the house, or a snowball, or any of the businesses you're working with have a Outpost? Let us know. Oh, yeah.
I know, at the moment, my customers that I'm working with at the moment aren't using any of those AWS provided hardware devices, but I know some that are. And so an Outpost is actually effectively like a big snow cone, right? It runs AWS services, so you have the same control plane to be able to run on-premise. So when you've got something that is required to run on-premise because it's at a location where you don't have like good connection to the internet or very low bandwidth to the internet, so you can't do that. You've got something that's extremely latency critical, or there's some sort of like regulatory requirement that it needs to be really close. So an Outpost has, there's a number of different services that will run on AWS Outposts, like much more than on the snow cone. I don't have the list in front of me, but so and that's what would look like. You'd get a machine, and there are like one down to 1 RU like racks that you can get as an Outpost. So you can get it like fairly granular, and you can build that up, and then you can run like a locked in version of like AWS cloud in your on-premise location, or within a data center as well. It could be as well if you needed to do that, and then you can build that sort of cloud at your local environment as well. The benefit there, the same way we've gone and talked about ECS Anywhere, is you have the same control plane to handle it. So you're not, going ahead and like standing up virtual machines and doing something different and configuring your own hypervisor. You have that all available for you. It's just spinning up EC2 instances. However, those EC2 instances are in the same room as you.
I think to me, like, if I had an Outpost, then I know that my test environment locally is going to definitely match what I'm deploying into the cloud.
You have
that would be
in there, Matt, to wheel it in, or?
I'll make room, but it would be pretty awesome if we have to get someone on the show that's got one in real life. But yep. Snow cone's the first. We haven't had someone with snow cone on so far, and I know that we're getting ourselves distracted because it's not a snow cone episode.
Yep. Maybe next time we can do a full snow cone and edge compute one.
Yeah, before we change topic over to, I guess, what we wanted to cover today, Mookie Monkey did ask, so the snow cone is connected to AWS. So maybe this is something that you can show when you go through the demo aspects that you've prepared, how you're communicating with the snow cone to do some of the demos that you've got planned. Maybe showing's the best way.
Yeah, sure.
Yeah.
All right.
Let's kick off event-driven architecture.
Sure. let me just share my screen.
Cool.
Make sure I've got the right one up. Now I'm going to share my entire screen, so hopefully you can see it. Can you see it okay?
It is up now, actually.
All right, great. All right. So what I've got here, and I'll zoom in, so give you a bit of time, but what we've done is developed a set of reference architectures that match a common set of enterprise integration patterns. So those familiar with integration and application architectures, there's many different patterns that were developed towards the early half of the year 2000s. And a lot of those are pretty timeless patterns in the way that they're used across, especially enterprises and other organizations. Obviously, there's some more contemporary patterns and stuff that do get used as well, depending on whether they're born in the cloud or whether they're not. But here is just I guess a sample set of some of the more common patterns that we've sort of worked with some of our customers. So let me just zoom in and hopefully you can see it okay. Let me know if you can't see it. All right, so each of these is really trying to call out some of the common patterns that we have, all right? So on the very far left-hand side here, I've got, this is a publish and subscribe pattern, or a one-way pattern to publish data. And yes, it is calling out some of the particular services that we do have here at AWS, but also relating these to some of the enterprise integration patterns that I mentioned earlier. So these are the integration styles that are used. So messaging, it's using message channels, and in terms of message routing, it's obviously using PubSub, message filters, and message broadcast in this case. So in this, say, we've got a publisher. It would actually then need to write a message, say, to a particular topic, and then there would be a number of subscribers that would sit off the back of that. Now, in this particular example, we've got a number of different actors. So in terms of this, we've got producers as EC2. It could be Lambda, it could be a container, it could be another machine on, it could be the snow cone, it could be depending on where it sits. And then the topic is actually utilizing the simple notification service, or SNS. And there are a series of subscribers here that can be used. So you can actually write that message directly as a fan out to SQS. It can go to a Lambda or a function in this case. It can go directly to an endpoint as part of a load balancer for a container, or it might just need to go externally to a separate API, which may not be within your organization. But so that's just an example.
You specifically called out like fan out. So there will be people that are not yet familiar with some of that terminology. So maybe just like reiterate what fan out means and what would that mean for organizations, and where might somebody use like a fan out terminology? Like what would that provide and what would that give?
Yeah, sure. I'm actually going to be demoing part of the fan out later. It's pretty rudimentary demo, but in terms of fan out in this case, as you can see, a publisher would take on one message, all right, and then there may need to be a number of different subscribers that sit behind those that need to get that exact same message in this case. So if you were utilizing a queue, typically you would only just pick up one particular message at that particular time. You'd have a number of workers that want to pick up that message. But I guess the benefit of that fan out pattern is it can broadcast that message to a number of subscribers in this case. And that way you might have, say, 3 different machines or 3 different applications that need these particular messages to do something. And they would each get a copy of that particular message if they're listening to, I guess, those events.
Yeah. So maybe like an example, a retail-based example, because I'm in retail, might be that someone's made a purchase. So that purchase is going to be sent as a message. So this purchase has specifically existed. I need the message to go to the receipts department so they could produce and build an email across the PDF invoice. A department that says, I need to check my stock ordering. I know that stock was in place. It allowed them to make the order, but I now need to go and trigger off something to say, should I do a reorder of that specific stock? Another message might go to the packing department to go ahead and get that item and put it into the packing trolley. And another one might be to the packaging department that says you need to go ahead and print off the label, and the label needs to be assigned to that box. So the mechanism to pass that message to 3 different people without having to write in something like what we would see in if we were to do that in code was you'd put a loop and you'd say do a call to all these 3 different services, however that might be. Here, that's taking care of that for you.
Yeah, that's right. Good example.
Right, I think the interesting one that, like, before we go on, is the HTTP endpoint. So a lot of people will think about like using like native integrations to those, like listening to a message. So listening to specifically a message off the back of like a Lambda function or another queue that's being processed somewhere else. But the HTTP endpoint is also like really valuable when you don't want to write yourself some middleware to do the transition between pulling that item off and then calling an endpoint. You can directly feed some sort of endpoint, like HTTP endpoint, to a secondary or external system, and SNS will publish that notification over HTTP and send the body of that message across.
An example of that would be, like, coming from my mobile development background, would be to a push server, right? If I wanted to send a notification to an end user, when you order things in Australia, like from a supplier, generally there's a third party that kind of tells you what's happening with shipping. So they'd be pushing a push notification out to that third party supplier to then have that push notification arrive back in your device with a kind of like a pre-prepared tracking number that nothing's really happened yet, but they've kind of booked with the supplier to use this reference code as they pick up your parcel, for example, and then all kind of like continuously send you push notifications throughout the life cycle of that delivery. Yeah,
that's a good example, and I'll actually cover like fan ad, as I mentioned before, as a part of the demo, and a subscription to a phone is a part of it.
Oh, awesome.
All right, so moving on. So similar pattern, or exactly the same pattern, but utilizing different service in this case. So different services from AWS. In this case, it's utilizing an Amazon MQ topic. So in the event that you didn't want to utilize the SNS topic in this case, perhaps you are using JMS or you have different protocols that you wanted to use, and it wasn't, say, a brand new service that was being created, and you're more familiar with the JMS constructs, then perhaps the MQ would be a good feature here. And Amazon MQ is a good one. It's actually like a fully managed service in terms of the Apache ActiveMQ product. And moving along, the same type of pattern in this case, but utilizing another service again. So this service here is using the Eventbridge. All right, so Amazon Eventbridge, and I presume you guys have spoken about this particular service on your show before, but some of the actors that I have in this particular example are obviously the producer being EC2. You can publish your event to the Eventbridge in this case. And the Eventbridge is a middleware service that provides content routing. All right, so you can actually publish messages to the Eventbridge, and you can create a set of rules, thereby those particular rules then route messages or route events, in this case, to downstream consumers. So I've got a couple of demos which will go through those, and we'll track some of the logs and see how that activity actually does take place. But Eventbridge is pretty cool because you can actually create your custom schema as a dev, and then you can actually create or set up schema discovery as a part of that, which makes it a little bit easier for developers in pools of large groups to check out all different types of schemas, and then you can actually load that in as an object in your code as well.
One of the really good features about Eventbridge is the replayability. Correct. In any of our other services, this will come up a bit when customers will say, like, what happens to my environment? Like, I don't know, if something goes wrong, if like something happens to our environment and it goes down, what do we do to populate a database or something? So in a disaster recovery scenario, you might have like, well, we'll restore from backup and we're taking a snapshot of the database every 1 hour, for argument's sake. With Eventbridge, And some of these like distributed event-driven systems, the idea of restoring your your databases and your application state may not necessarily have an idea of like restoring a database from backup or restoring from backup, but might be another mechanism to say we'll rehydrate the rest of our application and the state of our application and the end databases that are consuming that application by replaying all of those events all the way through. And Eventbridge allows you to go and say, for all of these events in this specific time period, like replay them through. And that might be really valuable when you've had like one, it could be a disaster, scenario where you have to rehydrate, but two could be that you've built another service and that service is going to, it's an addition to what you've currently got in operation, but you want that service to be able to like have access to all the messages that have happened in the past. So rather than writing some piece of code that goes to one of the existing databases, hooks into the database and direct connection, loop over that data and repopulate your environment, you can just replay a whole series of events on Eventbridge and push those messages exactly as if they were coming in at that point in time. So then you can build up that appropriate data set on the new service, for example.
Yeah, that's right. As a part of that, you have to create archives with it, and then you can replay from those particular periods. Yeah, one example that I've seen is when you've got different test environments, for instance, and you want to actually publish some of those messages to different environments, can be a common use case as well.
It's pretty cool because it's like a good way to reduce RPO because most people are doing snapshots or log shipping or something with the database, and there's always you're going to lose like a couple of hours of whatever it is in between. So if you can replay, it helps organizations reduce the RPO of their RTO.
So you said RPO, like not everybody will know that term. That's recovery point objective.
Yeah, that's right.
Like
yep.
You have RTO. RTO says if my service goes down, how long till I can get it back up again? And let's just say you've got 2 hours, so you can stand it back up. Your RPO says how much data can I afford to lose?
Yeah.
So if you have a scenario where you're backing up once per hour, well, you could lose an hour's worth of data, right? Because you've
maximum, right? Yeah.
Yeah, your maximum amount of data you could use is an hour because it's gone 59 minutes. Your platform's gone down. Your database is lost. The backup was run 59 minutes ago. You've lost 59 minutes of data. If you can do a replay through Eventbridge, well, you haven't lost any of that data. So your RPO goes like all the way down to effectively zero. And you can address that concern there.
Yeah, great example. All right, moving along. I'll go to the next example. Here we have is a publish and subscribe as well, but looking at it in form of a two-way approach as well. So publishing the message to the topic, then there's some form of subscribers that will take the event and then actually respond on a queue, utilizing the Amazon MQ service. The same approach, but using SNS and SQS, so Amazon's native application integration services. And then perhaps you could look at it in ways of using managed streaming for Kafka as well. So if you wanted to take events and then publish them onto, say, Kafka topics, you could do it in a similar fashion, perhaps on a more industrialized scale, and for large different types of volume. It really depends on what type of control you also want on your stack as well.
Yep. Kafka has some like really nice additional benefits, such as like KSQL. So you can run effectively SQL commands across messages as they come in real time to do combinations across different messages. So like some additional trickery there. Like Kafka is like much more all encompassing, I think. And we'll see a lot of customers that will come in and say, we've been running in a specific environment. We're carrying across with us some particular piece of legacy that Kafka is the only service that can control and do that. It's like, how do I say it? Like if you start using like SNS, Eventbridge, SQS, like they're quite nimble and very cloud native. Kafka is like a little more like bulkier and bigger. And you have to, like, whilst it's a managed service, you still have to spend some time like setting up your operational principles around like running and managing that cluster. Even though we'll patch and manage it up as it goes, you still need to take a little more care looking after that. Sorry, go, mate.
I was going to say, well, MSK serverless was a new feature that came out a little while ago. I think it was only like a month old. So we can take like a lot of the management responsibilities and make that easier for people with MSK serverless.
Yeah, that's right. So, because like those operational overheads that might come with running Kafka is, let's say for argument's sake, if you had SQS and all of a sudden, usually you're doing 5,000 messages a day, and all of a sudden you had like, I don't know, 100 million messages. Well, you can go ahead and do that. Like SQS will handle that for you. It'll take the amount of messages. It'll just work. Whereas Kafka would, you've picked a specific size for your Kafka cluster to run at. If you overload that, it will fall over. With MSK serverless, they've separated the storage and the compute aspect of that and enable that to scale up and down how you need it to go. So again, like taking away the operational burden from you to work out how to provision the size of the cluster that you're going to operate in.
Yep. All right, moving on. So there's another couple of examples we've got here. So looking at, say, request and reply as well. So some more simplistic, I guess, patterns that are perhaps used in a lot of enterprises. So in terms of the actors here, we've got EC2, we've got Lambda as a responder, and in terms of middleware, we're just using SQS queues in this case. Integration styles messaging, messaging systems, message channel. Our endpoints is using a polling consumer, and by that is the responder will sit there and poll for messages that are sitting on the queue or either requester. And in terms of message construction, it's using correlation identifiers. So, and what I mean by that is the requester will place a correlation ID that would sit on the particular message, and that would be mapped through to the responder. And then the actual event or the message that does get replied from the responder will publish that particular correlation ID back, so it understands what that particular response needs to be in this event. So in this case, you can see the reference architecture is quite simple in terms of just publish the message to the SQS, poll for the message, do what it needs to do on this case. It might need to do some form of processing in terms of a transaction, and then publish the response back onto a reply channel for the requester. Again, exactly the same type of construct, but utilizing Amazon MQ, and I guess the same type of example before, if you have different protocols you wanted to use, or if you're utilizing JMS. And then we've also got, say, large payloads as well. And Paul, we actually did some work on this with some other customers for some of the other work that we did as well. And that was in terms of messaging with large messages. And you can actually place, or you can use SQS or SNS as a facade. And you can interact with that directly, but those messages will actually route via S3 as a transient data store.
So what's an example of a large message? Are you talking about like large as in 20 megabytes or 20 gigabytes? And like what would you usually send as a message that's that large in size, considering messages are usually short and sweet, right?
So like that because we went through this a while ago on the show, like maybe six or 8 months ago we went through it. And there are limitations around the size of the message you can put on SQS, SNS, and Eventbridge, for example. And that might be one of the reasons why you start investigating MSK, for example. In this instance, you might be thinking about you'd like to think that the message you're sending has like one purpose and does one specific thing, but there may be something you've inherited that says, for whatever reason, we need to send like a large payload along the path. And that could be, I don't know, something that's like base 64 encoded, so some binary that's base 64 encoded, or something that has a whole bunch of complex relationships that you want to send a whole bunch of detail down the pipe. Andrew, what were the specific like areas that we were looking at? I think it was like they had a legacy system that was not able to be easily unpicked.
Yeah, I think it was a legacy system. Yeah, exactly. It was difficult to unpack, and perhaps had some cost constraints around that. So it sort of made sense to still utilize those messages as in their large form factor. I think they were in the megabytes at that stage, and that may have been like an aggregate of some messages as well. So in that case, there is options to use the extended library support for SNS and SQS, which is only available for Java as well.
Yeah, so Matt talked about the size. The size limit is 2 gig, so you can send like up to gigabyte messages along the path. And Andrew said it and very accurately said that SQS and SNS is the facade. You use and leverage the library in the way you would expect to send messages in and out of SNS and SQS. However, behind the scenes, these extended libraries will move, like put a notification and a message on the SQS queue with a reference point to some the file that's going to exist in an S3 bucket. And that file would be that message, whether it's something that's base64 encoded or like a very large JSON payload, whatever that might specifically be. And at the other end, again, the facade says, I'll pick that message up and I'll act upon that. But behind the scenes, it's actually going and retrieving that file from the S3 bucket and building it back up and showing it back to you as a specific payload there. If you wanted it in another language, you could go and that code is open source, so you can go and look at that code, see how that library's been implemented, and you can build that in other languages. And so I did a little bit of a proof of concept, sort of kind of did that in Python to do it. I didn't have the robustness of the language around it, but that's what you would do. That's how that facade works.
Yeah, great. Just checking on time, so I'll push through some of these, and then we can jump into the demos. And I've actually got a decision tree as well, which Paul and I did work on as a part of some of that work, and that can give some of the folks on the call a bit of an understanding of where maybe the best options to use some of these services as well. So here we've got a scattergather type of pattern. So in this case, it's utilizing very similar to the pub sub that we had before in terms of invoking the SNS topic. And then there may be a broadcast required where that same message needs to be sent to, say, 3 different targets in this case. And they may all respond in different ways. All right. So that those, in that case, would do what they need to do, and then they would actually send the response back to another queue. It would aggregate those particular messages back onto the queue, and then back for the requester in this case. So yeah, that's also a common one that gets utilized. In terms of the aggregator, I'll keep moving through, but this is the messages that are actually coming in. So you could inbound some of those messages based on batch IDs or TTLs, upload those messages, aggregate the messages utilizing a service we have called DynamoDB, and there could be other approaches for these, by querying those particular batch messages and utilizing some of the TTL events on those, and then aggregate those messages as a part of the function to an outbound queue. And then again, similar type of approach, but I guess in the reverse, is splitting messages. So you may have a delimiter where you want to split types of messages. And as before we said, there was really, really large messages. You may want to split them down based on some form of ID. So you've got options there to do it there. Just moving through. And we have a resequencer pattern as well. So if you wanted to resequence messages and they were getting out of order for some reason, I guess we probably haven't touched on these as well. Options for some of these types of queues and topics is what we call Fifo, or I guess standard queues. So first in, first out approaches. So you get the form of ordering. Sometimes messages will come out of order, and it's that type of delivery.
Yeah, when you use SNS and SQS without explicitly selecting FIFO, you should assume that those messages can come out of order. They may or they may not, but you should assume that they will be out of order, and that's fine if you have like a mechanism to like handle those messages to be out of order and like proper atomic responses and so forth. But if one message relies on another message, then FIFO, SNS implementation of FIFO or SQS implementation of FIFO could be very important for you.
Yeah, and you may have heaps and heaps of messages actually coming in from an end system that were coming from a number of disparate sources or disparate queues. And and they may be just all out of sequence, or need to come in some other form of sequence. So a resequencing pattern could assist in those cases. Enrichment, which is a pretty standard one as well. So you may want to enrich your data based on an API invocation. So you may need to get data from a particular database, or like a separate external database, for instance. And then you can just apply that particular update to the message, and then put it back into the inform response. API composition as a standard composition. So this is where you may want to make a request to an API. You may have a composer service within that, which will route those particular invocations to downstream services in this case. So you may want to get updates, say, from a student's database or something like that, and some information from another type of database, and those particular services would respond in that case, and then form the enriched response. I guess a good one that we've actually utilized for that is, well, not necessarily we've utilized it for that, but utilizing Graphql can be a good API composition pattern by default, by just passing in a single query, and then the aggregation takes place as a part of the service itself.
Yeah, we've talked about that a few times in the way that, like, leveraging AppSync and custom resolvers to be able to find that data across multiple distributed sources to pull it all back together. It is a very good mechanism for restitching data from multiple sources.
Yeah, so I've got an example of it here. I guess you can hit a graph endpoint, and then obviously you've got a number of different resolvers that sit behind that, and doesn't necessarily need to have that form of application layer we traditionally have. So you can actually go to, say, DynamoDB in this case as a direct point.
Yep.
Jumping back up to here, we've got some more contemporary patterns as well. So looking at, say, event choreography in this case. So you may have a number of separate microservices that want to publish messages as domain events. And basically you just want these particular pipes to emit those messages between each other and remove all the dependencies on those services that hang on the edge. So service number one in this case would emit an event to a particular queue. Service one would only know about this particular queue to receive messages from. It would only need to emit an event to this particular queue, for instance, and then so on. So what it does is then make sure that there's chaining, but it makes sure that there's isolation as a part of it. Another one is slightly different, but using event orchestration and using Saga patterns for those. So as a part of it, you could have a container which would have part of that orchestration for you, or you could utilize, say, one of our other services. It escapes my mind right now, and I don't know why. Step functions, sorry, to build out types of orchestration as a part of it, and that could be sitting there writing to separate queues in this case as well. That has a slightly different reliance on a particular service, though, in this case, and can be not as isolated as the example that I showed before. Another you can use is something like event streaming in this case, and this is just an example for, say, an audit mechanism. So perhaps you have 3 different microservices that are isolated, separate teams completely, and you wanted to then publish all of the events or the domain events that are going into a separate audit service, for instance, or you may want to put it to some form of analytics product as well. So you may want to publish this all to S3, and then you could read it in via, say, Redshift, via Spectrum or something like that. So you could publish those messages to each of these individual streams, and then this particular service here could then just read from them directly. And that way you've just got isolation completely. And the last one I had here was API composition again, but utilizing, say, like an Apollo gateway in this case. And that's just so you could build that out on, say, ECS using say Fargate in this case. But with this particular service, you could have a consolidated graph as a part of it. And you might have, say, a series of domain service graphs that may sit behind that, but you can actually deploy them to one single schema that always gets updated. So these particular teams could be isolated in their own way, and they just deploy to one single schema, and that gets updated as a single consolidated graph. So there'd only be a single endpoint in that case. So that's obviously a good one if you've got some very large scale stuff going on. All right, I'll just quickly jump over to the decision tree. I know we're sitting on time.
Maybe let's do the demos first, and we'll go through the decision tree later, because we have talked about the decision tree in the past. I think it'd be cool to see some of these demos and see where some of those events are being fanned out, and have a look at your code.
Yeah, sure. All right. What I'll do is, can you see that okay? And I might just make this a little bit bigger. I'll just go through
many terminals, which is good, and we can see a nice PowerPoint slide.
Non-tabbed terminals, but that's okay.
Yes, they are non-tab, and there's
no tmux or anything. No terminal windowing system.
There's a reason for that. I've seen this demo, Matt. There's a reason.
Okay. Yep.
So in this case, I'll just show, I guess, a few different demos. All right. So I've got 4 here, but number one, there's 2 parts to this. So there'll be I'll bring up the code. Might be easier just to show you what it looks like. But it's very rudimentary.
You might want to zoom in on that code, Andrew.
Yeah, I can do that. How's that?
You could go more. I think it's
another 2 command pluses or whatever.
How's
that? There we go. That's perfect.
Cool. Okay, so this is pretty rudimentary in nature, but it's just got, say, what I'm calling an event injector. All right. So for the demo purposes that I'm sort of presenting to you guys today, I've got a series of, I guess, variables that are sitting there saying, do you want some events? Do you want some messages to put on the queue? Do you want to receive messages? Do you want to publish messages? Do you want to publish stuff to API gateway, that sort of thing? And then there's a separate set of, I guess, calls that are being made to this utility service in this case, or utility class, that will then interact with the SDK directly as a part of it. So in this case, we've got submit event, which will put events directly into the Eventbridge. I've got submit message, and that will submit messages directly onto the queues. We've also got receive messages as well. So when you want to receive messages from queue, you may want to receive those particular messages at certain visibility, but you may not want to delete them as well. So this gives you options to delete those messages off the queue as well. There's also publishing messages directly to topics, and also invoking an endpoint just using some of the Axios modules you get with JavaScript as well.
That's probably a good point that you say there. So when you are leveraging SQS, you call SQS to get the message, then you call SQS to say, yeah, I confirm that I have got that message, because otherwise it won't be deleted out of the queue and somebody else can pick that up later. If you take the message off the queue and an exception is thrown within your code, for example, and you never acknowledge receipt of that specific message, then that message will become visible again in the queue for another process to pick that up after a period of time.
Yeah, that kind of brings me to a good point, though. Like, I've worked with customers beforehand that have not acknowledged the messages in the queue often enough, right? So they end up having an ever-growing queue. The idea with messaging queues, at least from what I've experienced, is that you want to keep the messages to like a count of 0, ideally, right? So you have things action, the message when it comes in, processes it, and you want to have these times where the queue's almost at 0, so it can actually do software updates on the queue and everything else like that. You don't want messages sitting there stuck forever, because they will cause you headaches and problems in the future when things kind of like stop working erratically due to memory problems or whatever else.
That's a really good point. Like, if you've got like an on sale for a ticketing event, you're expecting that queue to go really high, and it might take a day to build all the way down. But
that's fine. Yeah,
you'd expect your application at some point to go back to a 0 level amount of items in that queue.
Yeah, that's right. Yep. All right, so jump over to the slide just so you can actually see what the demos are going to look at. And I've just got a bit of a reference architecture on what it will do. But the first one will just invoke an API. It will then hit a Lambda function that sits behind that. And then there will be a domain event, which is actually being created on that particular microservice in this case, which will emit that domain event over to the Eventbridge. All right, and then there will be, as part of that message, it will have a routing rule, and this is the particular routing rule in this case, saying custom.producer contact one. All right, so I'm just saying this is basically anything that's taking on that particular message route will need to then take its route all the way to the register service, and it may need to register something in this example. And then again, it will emit the domain event from the register back to the Eventbridge, and then there will be updates taking place on the logs for this one. All right, so I'll take you through what this one looks like. Can you see that okay?
We can see your 7 terminals, 8 terminals.
Many terminals.
Yeah, you might need to zoom in on the terminals if we're to see the commands that you're running.
I will, and we'll just update this first of all. So we'll say, just update this to make sure that it's doing the right thing. First up, we'll say, let's invoke the gateway. And I'll make these a bit bigger. Just tell me if they're big enough or just need to go a bit bigger. Is that okay?
Yep.
Should be okay.
All right.
And hi, Capybara. I can see your messages there. And welcome from India, Japan, and the Philippines. All awesome locations in the Asia Pacific that I want to travel to in the next year. Now that we're back to travel mode across the world.
Yes, that would be fantastic.
Actually,
All right,
Paul,
so
you're going to India soon, aren't you?
I think I am going to India
Yeah.
soon. I'm picking up my visa at the moment, so that'll be my first journey over there to visit a set of customers. I'm interested in that.
Cool.
Nice one. So what I'm going to do here is I'm going to just inject that particular message, and what it's going to do is call this particular endpoint, this contact endpoint, and it's going to put in basically a dummy message into it, which will then be persisted to a database. In this case, it's going to Dynamo, and then that message will be emitted off onto the Eventbridge. And what I've got here as a part of these particular terminals and what they play is these are, I guess, the logs that are sitting on each of those. So this is the first microservice. This is a second microservice in this case, and this is the CloudWatch logs where it's all being persisted to. So what I'll do is I'll kick that off, and it'll just sit there and flow through.
So, and for those logs, we're saying that those are all separate microservices, all on potentially different infrastructure, and definitely different infrastructure in here. And they are all listening for events off the back of that event that you're going to inject.
Correct. Yep. So I'll bring this back. I'll just quickly hit update. All right. So it's got a response, and now I can see the messages that are coming through. All right. This has got, because it's sitting on CloudWatch, it's probably got a little bit of eventual consistency in terms of the data that gets updated. So it might look like it's coming out of date, but yeah, this is the contact service. This is the register service that I showed before, and this is the CloudWatch. So you can see here, the event contains, I guess, the payload that was put through based on, I guess, the particular source that's been pushed. And then all that message routes through from end to end.
Yep. And that probably gives a good overview of when you are fanning out messages, or you've got a sequence of messages in happen, these things don't always happen at the same time. So that's why you see, certain of the services may pick the message up first. They might act first. One of those microservices might take a long time to do its action and then go ahead and log that out. Because, in each one of those terminals, I'm pretty sure, I can't quite zoom in, but you're just tailing the CloudWatch logs, right?
Yeah, that's right. So as you can see here, I'm just, can you see that okay? Or I need to go in a bit further?
Yeah, that's good. That's much more clear.
Okay, so here, my thing is it's just basically tailing the log group that's sitting there from that. So anything that's coming out and all being written from the console as part of that function, it will provide that information.
Yeah, but we got a question from the audience from GekDev, and he says, is there any news on whether the average latency of Eventbridge will be improved to be closer to SNS? So it would probably be like I don't specifically know the average latency difference between the two services, and that would depend on what you're trying to implement that is like very, very latency sensitive. Get dev to get some specific granular information around that. If you've got an account manager, reach out to them and they might be able to look that up and be able to provide some information. I know that Eventbridge as a service has a lot of backlogged items, so it is a relatively new service in comparison to SQS and SNS. So there's many different improvements that are coming along the line. If you don't have an account manager, reach out to one of us. Yeah, so GekDev says the AWS says that the average message latency for Eventbridge is half a second. We're going to provide that sort of information because it could be less, but that would be the average one.
Okay. All right, let's move on to the next one. Similar type of approach here. I mean, it's just basically doing event routing, but I'm injecting the messages directly onto the Eventbridge and utilizing the put events API that does have. So I'll just move these out of the way so we can see it. And let me know if these are big enough to see.
It's okay. In the background, we've got Mittens, who obviously really likes Vim. So that's cool to see.
I think that's a very nice little icon there, Vim. I have a Vim sticker just like that.
It's cool. Yeah. Vim's fun, but I think for screen sharing, VS Code works really good as well.
Certainly. All right, so we'll come back to here and we'll just quickly update this. And then what we're going to do is publish a series of events that we want to place on. All right, so we'll say 50. And what it's going to do is there's some hard-coded domain events that I've created. It's actually going to write them directly to this AWS Tech Demo event bus. And there's going to be a number of different sources. So based on source number 1 or source number 2 or source number 3, it will route that message to the appropriate services in those cases. All right. So we'll save that. We'll inject those messages. You can see those messages are being placed. And now we'll start to see them come in.
So all of these node applications are just sort of running on your local machine, but they're connecting in and just tailing those logs. All those events are being injected from your local machine directly against the API to inject events into Eventbridge, just to demonstrate the purpose.
So this node application is running on my local machine, just the one for the utilities, just for demo purposes in this case, but all the other stuff's running on the cloud in this case. So they're all either separate microservices running on Lambda and utilizing Eventbridge as part of it. All right, so you can see that all the data's come through for these, and you can see these are the particular payloads that are coming in. So depending on what you wanted to do with it, you could pick up that particular message and then route that off somewhere else, or ingest that message and persist it, or do what you need to. All right, so the next one we'll look at is the fan out. So we spoke about fan out earlier. And in this case, we'll just have, we'll publish a single message, and one will go to an event store and it'll write this message to the particular log. We'll have another one which will go to my phone. So I've got a subscription based on my phone, and also from an email in this case. All right. So let's update that. And we'll remove all those messages. And we'll say we want it to come through, and we'll give it something really nice to say. And I think I updated it earlier. Dev's in the shed for the win.
Oh, nice.
Just for you. And we'll pop that message on. And we can see the message ID has come back. suspect we'll get one of these coming. Close off these ones that have just completed. So here I can see that particular message has come through, and that was for the first one. You can see message has been received. Dev's in the shed for the win, if you can see that.
Yep.
And yeah, I've also got a message that's come through as well.
Nice.
So yeah, that in that case, that's really a good one, just to broadcast messages out. And the last one I've got here is the SQS being used as a message broker, and we'll just submit some messages directly onto the queue. It'll go to a connection service. In this case, it will just take a message event, and then it'll do what it needs to do with it, and then place a response onto a separate queue that will go back to, I guess, the publishing message, or the service at this time. So let me just bring back up my console. Sorry
so
for audio.
Good, we think about event-driven architecture. That something's going to trigger something when a message comes in as an event. But in this instance, you can have effectively wait on an event coming in, continuously poll, continuously poll. Yep.
Yep. So we'll place, say, 5 messages on the queue in this case. I'll just get rid of these, sorry. This is the connection one. We expect it to come off too.
Maybe zoom the font in for that one a little bit. It's still a bit hard to see.
Okay. I'll just kick that off. We'll put some messages on it. I expect it to come through at the base here. So this is polling all the time for those particular messages, as I said before. I can see the messages that come through now.
Cool.
So yeah, that's come through relatively quickly for this particular case. Where is the message payload? If I can see it in this case. 25.
The body of the message is message name change?
The body of the message. Where am I?
Yep. And the body is message name change, really close to the bottom. Yep. Yeah, I can see it there.
Very good. Yep. And then what we'll do now is we'll receive those particular messages off the queue. Okay. And that's off that actual response queue in this case. All right. So what we've just done here is place the messages onto this queue, and then that connection service has polled directly and requested those and done what it needs to. What we're going to do now is this particular service that's running on my machine is just going to poll this response queue and take those messages off it. All right, so we'll receive a message. We're not going to place anything back on. And what we should see is the actual terminal. Play this out. All right, so we can start to see messages being deleted. Message has been deleted, and that was the original request ID. But yeah, that was the message that was placed on there. It was just, good morning, this is a lightweight response, and touche, it's the afternoon now, but you can see that's come through, and we'll see if there's anything else left on the queue. And as you can see, the message queue is now empty.
Cool.
So yeah, that's, I guess, what I had in terms of demos, to sort of provide some of the more common approaches to some of the integration patterns that we see within the industry.
Yeah, we actually had a question that might actually tie perfectly back into what we're just about to cover. Yep. But Liquid Sewer asked when to switch to Kafka or manage Kafka from SQS and SNS. That made me think of exactly this diagram, right? It's like what's your business case? What are you trying to do? So let's have a look at this quickly.
Yeah, sure. Okay. So what this is actually basically a decision tree that we put together to help us understand what technology to actually select based on a series of commonly asked questions. All right. And those commonly asked questions are basically features as branches within this decision tree. So number one, and hopefully you can see this okay, is is the input to this is a message, and it's the message size. So the first question you need to ask is it above 256K, or is your messages always less than 256K? So in this case, we could say they're always going to be less than, in this case. And then if you, the second question you might ask yourself is, do you want just standard one-to-one integration in this case, or do you want more broadcast in this case? We could say that, yes, we want to have, we don't want to have any broadcast. We just have, say, one-to-one integration as a part of that. The next question you may ask yourself is, do you need archival or replay as a part of that? And we spoke about some of those services earlier around Eventbridge, and obviously Kafka also provides these types of services as well, or these features. So you could say, no, I don't want it in this case, or yes, we do want it. So we could say, yes, we do. And we could say, okay, actually, no, we'll say no for this case. Do we need a router for this case? We could say, yes, we do need a router for what we need. And that could be in the case of either content routing or filtering in that point. And then the last, I guess, question that gets placed onto it would be, do you need ordering as a part of that? And we could say yes. And then what this does is then bring you down to, I guess, a service selection. And hopefully you can see that okay. But what it's saying is SQS or SNS FIFO. So using those particular services to get to it. So yeah, this one is a common one that we've used with some of our customers just to help them understand, I guess, all the types of questions that you ask yourself when looking to select application integration services.
And maybe like going back to like Liquid's specific question, this specific flowchart that Andrew and I worked on and built out was really going back to saying, how could we use the cloud native services to be able to build some of that those mechanisms? So you can see there's custom 1, custom 2, some of those boxes. Right. Those customs, we had like custom constructs on the back of that to be able to store like ordering and so forth, like within DynamoDB to handle some of those features. And that would be if you were not wanting to implement something like Kafka. If you were wanting like all of this to be fully managed by a centralized platform and you were happy to take on running and working with Kafka, a lot of this, Kafka can cover off a lot of these scenarios, but comes at a higher operating cost. And I think that's the differentiation. You have to understand what it is your organization is willing to take on and own in a custom construct versus how much do they want to like offload and push to like a managed service such as Kafka or Kafka serverless for that. So usually like what it will come down to is, I'll say this like fairly flippantly because it depends on the use case, but Kafka or MSK will typically cost you more than it will cost using those native AWS services. And also you don't have the infinite scalability that you have when you're using like SNS and those cloud native services there. So again, it's very difficult to answer the question of like when to switch because it will depend heavily on the use case and what you're trying to do. One of the reasons that people will want to use Kafka is because they want to do in-flight querying across specific topics. And use like KSQL to be able to go ahead and do that. That's one thing that you can't necessarily do. But a lot of the rest of it, you can build your own constructs on top of our native services. And a lot of those constructs were reasonably small. So we did demo that a while ago. They weren't overly bearing what you had to go ahead and do. And you build and deploy that once and it's just handled for that application.
Yeah. This one in particular, what we did put together was basically giving the ability to have message archival and message replay with some of those more native services, as Paul says. So what this was doing in this case was taking a particular source, might have been a queue or a topic in this case, writing that message always to an archive. That message was going to an S3 bucket, and Paul coined it the message bunker in this case. And then those particular messages would be partitioned, and then there'll be some metadata provided for those to Dynamo. But what it did is give you the ability then to use a series of APIs whereby you could then start to retrieve the message by date. You could, or a series of messages by date. You could retrieve a message by its original ID. You could replay the message by its ID, and then you could replay it by date in particular sequence, and then that would actually place it back onto the original destination queue or destination topics in this case.
Well, yeah. So what we kind of built, or what the end result was a semi replacement for MSK, but like our own custom pieces of code that sat on top of that. I mean, it wasn't production ready, but that was the idea behind it, to be able to, replay large messages from native AWS constructs.
Yeah,
the interesting thing is kind of rewinding just a step back. But usually when I've seen MSK, it's usually because there's Kafka on premise and they want to have some form of replication of the messages. So I think in the real world, I actually haven't run into the use cases that you both talked about. It's usually been you've got Kafka somewhere, you want to replicate that to cloud.
Yeah, it depends. I have customers running Kafka on greenfield projects because they want to take advantage of some of those specific features of Kafka. There are some nice features that Kafka offers.
Yeah.
Yep.
So Andrew Mittens, the Keyboard Bunny, asked whether there's a link to this flowchart. I'm not sure if we're able to publish that or not. We can kind of look at that, and we'll update the YouTube videos at the end with the reference for that. Matt, do you want to quickly paste our YouTube channel so people can subscribe? That's where we'll provide any updates.
Yeah, no problems at all. So here is the link for everyone. Should come through now.
Stop sharing my screen, just I'll
take it down. Here we go.
I don't know whether it's ready today, but at some point it'd be nice to be able for people to have access to that code to look at it, because there are people that will say, I get what you're saying, but let me play with it. Let me see it hands-on. Let me see what that looks like. So I think that might be would be very useful for some people. I think it's very useful to go back to what the theory was and our patterns, to then show in code what some of that looks like and see those events coming through, see how things take, there's some time involved. It's not instant, these things running, and how you can communicate between different applications, different languages, and different compute runtimes.
Yeah, definitely. Whilst I actually do have it, I forgot to go through it in part of detail. Let me bring it up. But it was actually the CDK constructs for some of these particular patterns as well. I can show you one example, for instance.
Nice. I think 50% of the audience here or more uses CDK now. Let me know in the audience if that's correct or not. But Paul, myself, and Aaron are always touting how great CDK is. I'll share your screen when it's ready.
Awesome. Now, this was I haven't really played a whole heap with CDK, but this was just a good way to get into it. Can you see that? Okay.
It's coming back up now. Yep, here we go.
Cool. Okay. So what I'd done here was had a pub sub stack in this case, and it was basically just an approach to build out the publish and subscribe model. So if you had a particular function that was publishing content and receiving functions, then it was just a method to apply these quickly and efficiently in this case. So I've been trying to build these out slowly for some of the other patterns as well, so it can be quite useful. But this is basically just the actual stack piece rather than anything else.
Yeah, awesome. Right. Yeah, I think when we had the original piece, some of those custom constructs were built into CDK too. I'd have to go back and remember what we did, but I remember building some of that stuff out in CDK as well.
Yeah, cool.
And as a developer, this is a great way to quickly build, your messaging infrastructure very quickly, and then you can get back to focusing on the application side as well. So this is why I love CDK. It's knock up some infrastructure. Now I've got my my event architecture set up, and I'm good to go for the next thing. We do have another thing in from GecDev, so let me just have a read of this. I'd be interested in a video where you guys import existing AWS resources into a new stack. I've actually written blogs on this, to be honest. I think we did do a short video as well, didn't we, Paul?
I think we touched on it, but I knew the blog. I was looking at it now because this is something that came up a few times. But maybe we can go and redo that again.
Yeah, I think we talked about it, and then we wrote it into a blog. So we only talked about it briefly on an episode.
Yeah, maybe we didn't actually do it, but on the show. But yeah, that could be worthwhile doing and taking people through like an example of that. I found the book.
Oh, yeah, I've posted the links. Like the first blog is how do I import like things that are sitting within my VPC already, like even importing my existing VPC. The second one is like how do I reference what was it? Let me have a look. It's been so long since I've actually looked at it. How do I use identifiers within CDK? And I think the third thing that we probably need to show in the future or write an article on as well is how do we use custom constructs as well. So that's something that people want to do with CDK all the time. And we probably should do a session on like how to use multiple stacks effectively as well, because I do see a lot of people trip up when they create multiple stacks and they move their resources between the two stacks and they find out that their RDS database has been recreated elsewhere. But maybe we need to do another session on CDK in the future, because it's one of the most fun things we can play with.
Awesome.
Yeah, it's a popular one too.
Yeah. Well, thanks so much, Andrew. Like we had so much content, we ran over nearly 20 minutes. Thanks for everybody that became and Nested Stacks to GecDev. Yeah, that's right. So many questions from the audience. Really interesting to go through all of that, and it'd be awesome if at some point in the future we can get some reference points to some of those architecture diagrams and guidance, so that people can leverage the hard work that you've put in behind that, Andrew.
Yeah, absolutely. I can publish some content and get in touch.
Cool. Well, thanks everybody. We're going to end the stream now. Andrew, just hang along once we end the broadcast. And yeah, catch everybody again at the same time, same place next week.
NLP, so natural language processing, I think we've got in store for everyone next week. We've got a machine learning specialist coming.
Yeah, I'm going to have to duck out from that training course because I'll be up in Sydney that week. So it'll probably be in like some hallway or something, but it should be fun. It'll be devs in the hallway, I guess.
It'll be devs in Sydney and Barossa Valley.
Right. So, we're all distributed next week.
Yep. Or maybe Aaron will be around in his shed. He can be the shedder. Anyways,
he can be the anchor.
Let's wrap it up. Thanks everyone for joining us, and we'll catch you same time next week. Thanks everyone. Bye.
Thanks, Andrew.
Thanks Andrew as well.